Coming up on StarTalk, we speak with my friend and colleague, Aomawa Shields. She's an associate professor of astronomy specializing in astrobiology at UC Irvine. And we talk about the search for life on planets that are already known to exist in orbit around their host stars. We're going to learn what M stars are. We're going to find out what the color of the star has to do with what life might be like on a planet's surface that orbits it. And we'll also take questions, cosmic queries from our Patreon members. All that and more coming right up. This is StarTalk. Neil deGrasse Tyson here, your personal astrophysicist. I got Chuck Nice with me. Chuck.
Yes.
Always good to have you, man. Doing it again. The universe is nonstop.
That's right.
And it is continually...
Is it really though, Neil? Is it really?
Yes.
Does it? I mean, seriously, can we say with certitude that the universe does not stop? I mean,
if there's anything in the universe that doesn't stop, it's the universe itself.
There you go.
Well, bam.
Okay. I'm gonna see your statement and raise you entropy. So
today we're talking about life on other planets.
Yes,
life on other planets, and we're bringing in a friend and colleague, Aomawa Shields.
Thank you so much, Neil. I'm excited to be here.
So she's an astrophysicist and more specifically an astrobiologist, which is kind of a new field, new in the last few decades. I'm old enough to call that new. Also on the landscape of science communication, she's there and she's a force. She's an associate professor in the Department of Physics and Astronomy at UC Irvine and founder of Rising Stargirls, a program dedicated to helping girls discover the universe.
What?
I know.
Watch out.
Also a trained actor.
What?
Oh, I know.
Wait a minute.
I know.
Wait a second.
Wait. But I'm not done.
Oh,
go ahead. Until I'm done. All right. Now she's got a new book out. Oh, wait, now you can react.
What?
And she's got a new book, Life on Other Planets, a memoir of finding my place in the universe. Whoa. Aomawa, welcome back to StarTalk. I think we've had you on before, haven't we?
You have. Thank you.
Yes.
It's wonderful to be back. Last time we were talking about terraforming Mars, and now we get to talk about more life on other planets, places where there actually could be life, although maybe Mars, I don't know.
Yeah, plus I want to get to the bottom of what it means to have a book titled Life on Other Planets, and now you call it a memoir. Chuck, I think she's an alien.
Okay, that's what I'm saying.
This is the evidence we need.
How was the trip?
I have a lot to share. I have a lot of information now. Yes.
So we'll get to your book a little later, but let me just can you update us on where are we in the search for life in the universe? Because you focus on the habitability of exoplanets and in multi-planet systems, what climate might be on those planets. So what are you doing when you go to work each day?
Yes. So my team's work starts after the planets have actually been found. So it's hard enough, as you know, to find a planet around another star. And it's
although we are going like gangbusters, we're approaching 6,000 planets.
That's right.
So yeah.
You know, and that's that's the tiniest fraction of our own galaxy. Never mind the fact that we have 100 billion plus galaxies in this universe.
Right.
But yeah, we've got close to 6,000 now that we've found. And so, but we don't really know anything about how habitable they might be, whether they might have water on their surfaces, which is what we define as habitable, because we know all life on Earth needs water. Everything from the tallest, largest elephant to the smallest, teeniest microbe needs water.
But you just confessed that you're completely biased, because you're not just looking for life, you're looking for Earth life.
Yeah. That is true. That is true. And this is why
I just want you to fess up
yes,
right here and now.
Thank you.
Show your cards. Okay, go.
Very true. And this is why the field of astrobiology is so important, because there are astrobiologists like me who are looking for planets that might be warm enough for liquid water on the surface, but not too warm. And there are also astrobiologists whose job it is to ask the question, what about life as we do not know it? What about non-Earth-like life? Could life use something else besides water or something else besides carbon as in its backbone? So that's really important. We can't be so Earth-focused that we miss discovering life because of that. So it's true. But
because I've seen some missions, they're looking for Earth-like planets around sun-like stars. You can't get more sort of biased than that, it seems.
True. And sun-like stars are not the majority of the stars in our galaxy. The majority of the stars in our galaxy are actually much cooler, smaller, and redder than the sun. So that sounds
to me like we should be looking there.
Okay.
I have spent a lot of my career focusing on that, right? These M stars, these cool small stars.
M. So we're a G star. Sun is a G star.
Yeah.
So what OBA of GKM. So M is like the coldest star category we have. So why would you think?
It's pretty cold. We know of some even cooler ones now, like L's and T's, but then there's been some controversy. Are those really stars? Are we getting so cool that we're in the like brown dwarf regime? But
and just to be clear, when an astrophysicist refers to a cool star, we're talking a few thousand degrees.
It's still really hot.
Not Robert Downey Jr.
You would still be incinerated.
Yeah, it's all relative.
Right. So how do you modify your search for life around an M dwarf star?
Yeah.
If you know it's not as warm as the sun. So what happens to the habitable zone and other sort of properties that you're seeking?
That's right. So if we want to look for a planet that could be what we call this habitable zone or the Goldilocks zone, because it's not too close to its star, not too far away, so it's not too hot, not too cold, we have to look much closer to an M star than we would to around a sun-like star. In the same way that if you're, say you're on the beach and you're crowding around a little campfire, you're going to have to stand much closer to that campfire to get the same amount of heat as you would if that campfire was a bonfire. Right? The same principle exists when we talk about these cool stars versus the hotter stars. So we're really
it just redraws your habitable zone. That's all it does.
Yeah, so it smushes it closer up. And there's some interesting things that can happen when a planet is orbiting that close into its star. Right? There's forces at work. Yeah. There's tides. Right. The planet pushes on the star pushes on the planet, and the planet's rotation period can get slowed down, and maybe even to the extreme case where there's one permanent day side, and the other side, it's always night. And we call that situation synchronous rotation. It's like this extreme case of tidal locking, and it's literally always day on the day side, always night on the night side. And
that
my
can't be good for life.
People have thought that it would be
not if you want
really
nap.
bad.
Right, yeah.
That's right. And they're like, it could get too...
How are you going to put life on a
maybe
planet
you just
like
have
that?
like a work side of the planet and a party side of the planet.
I like it. Disco lights on the night side?
You don't wait for night to come.
Yeah, you go tonight.
You go tonight. Oh,
right?
Chuck.
It's like, yo, what you doing later? Yo, I'm going over tonight, bro. And we gonna chop it up crazy like.
And,
all right, that works.
So that has been a big concern. However, fresh off the presses, my team actually has some new work that shows that you could have life along the Terminator. Dun 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 dun. Right. The dividing line between the day and the night side. That's what we call the Terminator.
So temperature-wise, if it's always night and you're just never facing anything, that would be like a super cold part of the planet, right?
Right. Yeah. And then if they're always daytime, that would
be a super hot part, right?
So there's got to be a spot that's just right.
Right.
Yeah.
Okay.
And that,
and it's funny, the just right spot you call the Terminator.
Right? So much more amenable, much more neutral than our pop fiction Schwarzenegger Terminator.
Right.
But I cannot help. We coined this term Terminator Habitable, and that's the name of our paper. And like,
it's so doubly comfortable. It's very comfortable. It's like a warm bath.
So before we continue, let me, if I may, I will give a brief tutorial on how stars got the letter classifications. So you go back 120 years, we're getting data on stars that are not just pictures of them, but spectra. And we don't know what spectra are yet because quantum physics wasn't yet discovered. But we knew some spectra look like others, and you could put them on a continuum, and that transition from one kind of spectrum to another. And so we did that. And we lettered them A, B, C, D, E, F, G, H, I, K, L, M, N, O, P. Okay. Then quantum physics came around, and we said, yo, there are reasons why the spectra look this way, and it's not what you're thinking. And it had to do with the temperature of the star. And it turns out these features can duplicate between being too cool to have a feature and too warm to have that same feature. By the time we shuffled these letters into a temperature sequence, A, B, C, D, E, F, G became O, B, A, F, G, K, M. And why didn't we just re-letter them, which I think we should have at the time? But we didn't. Okay, so we have this artifact.
Could have gone with numbers. Pretty simple.
Yeah, because now we get to confuse astronomy students the world over, year after year.
Forever and ever and ever.
Every year I get that
O stars
question.
are hot, and B stars are next hottest, at O, B, A, G, we're G star. And then each category is split into 10 other subcategories. Yeah. Okay, 0 through 9. So we are a G2. Okay, Arabic numeral 2. Okay, and we divided them by what's called luminosity class, like how big are you? And so we have classes 1 through 5, or 4, or 3, 5. And so we are G, Roman numeral 2, G, Arabic numeral 2, Roman numeral 5. Wow. If you tell that to an astrophysicist, they know exactly what kind of star you're talking about.
G25.
Yeah, it's code. Right. That's what it is.
Sounds like something that rappers fly to their next concert in.
That's right.
What wouldn't it be?
The summit.
Yeah. G25, baby.
So Aomawa, tell me what did you need to do to model a Terminator habitability? Like what kind of calculations were necessary there?
Yes, and I have to give a shout out to my postdoc, Anna Lobo, who's spearheaded this work. And we had to ask that question. As I write in the book, that having this question, could these planets even exist? It's the first place to start for any scientist or any curious person.
That helps. Before you invent life on a planet, make sure that kind of planet exists.
Could actually exist. Mm-hmm. And the first thing we had to do, we're using models, climate models that are normally used to predict the climate on Earth. So they're the same models that have been used to predict the effects of climate change into the 2100s. The reason why we know that climate change is real and that it's going to continue unless we do something is in part because we're using these models to forecast those effects. But what we're doing...
And these models, so all you have to do is change some of they probably have knobs you can turn.
That's right.
Where everything else, because the physics would just be the physics, but the rotation rate and the sun's energy entering the system. Right. These are knobs, right? Oh,
these are cool. Knobs that we can turn.
I didn't know these are general climate models. Fascinating.
That's right. So we are changing the spectrum of the host star, right? How its energy, its light is distributed across the whole spectrum is going to be different depending on the temperature of the star, the type of star. We're changing how the shape of its orbit, how much is in its how much atmosphere, like what its atmospheric composition is. Because we don't know those things for Earth-sized planets. We have no information about the type of atmospheres they might have or their surfaces. And understanding the effects on climate of different types of atmospheres is going to help us understand which of these nearly 6,000 planets we want to prioritize and look at with the next large generation telescopes to find out if there really is life there.
So this is a beautiful example of the cross-pollination between two otherwise very different disciplines.
Yes.
Like you go into climate science, folks, they don't care about exoplanets, right? They just care about Earth, right?
I know, and I'm on a personal crusade to change that. Because it's true, like it's so interdisciplinary. We're using atmospheric science, climate science, astronomy, geology in some cases, glaciology, because I'm all about ice and different types of ices and because different types of ices interact with different types of light, depending on the type of ice. There's more than just water ice. We're looking at CO2 ice.
So different ice would reflect their sunlight differently from other kinds of surfaces, and would change how much energy enters the system. Is that
right?
Fair? Did I say that right?
That's exactly right.
How does all this fold into this book that you just wrote?
I'm so excited for this book. This has been a dream of mine for a long time, and as you know, I was an astronomer, then I changed and studied acting, and then I came back and finished my PhD and became a professional astronomer and a professor. And for the longest time, I was trying to reconcile these two things that I loved, acting and astronomy. And I thought that they couldn't coexist. I thought I had to choose. And when I would share with people those two loves, I got a lot of like, what? This is so strange. Why? How? And I think I internalized that and tried to, figure it out. And it was funny because when I stopped figuring it out, these incredible miracles got to happen where I saw how they can really coexist, like hosting a science TV show, which I could never have planned on my own. Eventually going back to grad school, in part because of your suggestion and, being put in touch with you and your mentorship. And also I had applied to the astronaut candidate program and had not reached the next level. It was like everything was saying, go back, get your PhD. And I finally became willing to listen. And so the book really is about that whole journey. It's about why I fell in love with the stars and the night sky, and why I fell in love with acting, and this whole edge that I carried for a long time of like feeling like I was an astronomer or a scientist around actors, feeling like I was an actor around scientists, and eventually coming into full acceptance of this non-traditional background that I had and how it could really make me a better scientist and a better communicator because of it. But it's about the whole journey.
First of all, that's beautiful what you just said, because it's a reconciliation of self, which I think is always a wonderful thing that anyone has ever.
Doc, you could be a counselor. You could be like a therapist.
Yeah, if you want to mess up your life. But
okay. No, I think if you have these loves, I too had sort of secondary pathways, but none as significant in my life as your acting was. But I just did little things. I doodled, and I liked calligraphy when I should have been doing other things. But now when I sign my books, I use a calligraphic pen. And the people who receive the book, they appreciate it that much. With little things like that, you find a way to fold it in. Your life and the lives of others are much more enriched. So I'm so glad that you pursued what you loved rather than what people thought you should be doing.
Thank you. I have to say, I still remember, and you're going to find out. You probably read parts of it already, but if not, you'll see later. Like, you're in the book.
I'm in the book. Okay.
Wait a minute. Am I in the book?
You're going to have to read it to find out.
And you're in the book. And you're in the book.
And
everyone.
Who isn't in the book? There are a lot of people who are in the book. But like I write about that moment when, I first met you in person at the AAS, the
Yes.
American Astronomical Society. That's our professional conference for those who don't know what AAS means. And we sat, on some umbrella chairs or whatever, and people were walking by like, is that who we think it is? Is that Neil deGrasse Tyson? And, and you were just there. And I think I started to cry at one point because I had, we'd been talking about my background and how I had, there were ups and downs. I had struggled academically because my head was not in the place, like my heart and my head were not in the same place.
It's funny because I cried when I met Neil too.
Stop.
But that's because he was standing on my foot the whole time he was talking to me. And he's a big guy. I'm telling you, he's a large man. It was not pleasant.
Wait, Aomawa. Plus, it didn't help matters that you also married an actor. Isn't that right? If I remember correctly, is that correct?
I did, yes. And he is 100% actor. He doesn't have the my actor, scientist, engineer, architect.
Distraction.
He's 100% actor, although he does enjoy those doomsday Nat Geo shows or Super Volcano or
Okay, yeah.
And
that's in us.
he's
But
a
what
lot.
I'm saying is that would have been a force that would have been supportive of your acting, correct? I presume.
Absolutely. We met in acting grad school. He was my classmate.
Oh, okay.
wow.
So at
You
UCLA.
were becoming a real actor. She said acting grad school.
Yes.
Okay.
Well,
Listen.
this is the.
That's the real stuff, okay?
Yeah,
That's when you're just like, you know how people say, well, I'm going to be an actor, and they're like, well, you're never going to get a job. When you say, I'm going to acting grad school, they'll be like, oh, you getting a job.
One would hope. That's what we hoped and expected. That wasn't always the case, but yes, like I wanted to study it in the same way that I studied astronomy. And that was so much fun. So I had left the PhD program that I was struggling academically in, and I had an old white male professor tell me to consider other career options, and and I internalized that and left. And when I got to acting grad school, it was like I was free. I felt so light. But it wasn't like it was easier compared to astronomy grad school. It was harder in a different way. And I write about this. It was like it wasn't necessarily about the brain cells working overtime. It was about dredging up my emotions and feelings and childhood experiences and like bringing it all up, that I needed to use it to embody
summoning
these different
it on
characters.
command.
Yes.
Summoning it on command, yeah.
It's got to be real. It's got to be real.
Yeah. So you stitched this, you made a tapestry of your life with your professional ambitions in this book. So it's part memoir, part advice column. Is that fair?
Yeah, there's certainly, it's all spoken for the most part in the first person. Like, this is what I did. This is what helped me make my life better and reconcile these different parts of myself. And I hope that I'm writing it for the people that have that question of like, is it too late? There's that part of me that I never could, bring up into my life. But it's always been there. Like I say in the book, it's when you leave a dream behind, it never dies. It's like sitting on the side of the road, and eventually it'll catch up. And that's what happened for me, and the message of the book is that it's not too late, and that if there's no role model that's doing what you want to do, you can be your own role model.
Yeah. That's right. And in fact, if you always needed a role model, you would only ever do things that other people did before you. But sometimes you have to trailblaze. And like you just said, if you become your own role model, that's harder, of course. And you got to figure things out on the fly. But if and when you succeed, then people say, of course, that's what I always wanted to do. Those who come behind you. So just congratulations on that.
Thank you.
Fantastic.
Well, Chuck, let's get to some queries.
All right, why not?
Specially tuned for this visit.
Absolutely.
These are questions from our Patreon members?
Patreon patrons who just for a paltry, almost insignificant $5 a month. This is Mike Parker, and Mike Parker says, hello, Dr. Shields. Mike Parker here from Richmond, Virginia. If life does exist in our solar system, which planet or moon do you think offers the most promising location?
I love it. In fact, give me the top 3 cases in order.
Oh my gosh. Okay. This is a fantastic question. Thank you for asking it. Europa, which is Jupiter, a moon of Jupiter, would be my top. Even though there's a lot of buzz right now around Saturn's moon Enceladus, which would be my number 2, the next one. Saturn's moon Enceladus has geysers of liquid water that are shooting out from its south pole, and there was a reason.
Can't argue with geysers.
And apparently all of the basic elements of life are there.
There you go. Geysers lead to geysers. Geysers lead to geysers.
Chuck, I don't think that's how language works.
Okay.
And then, gosh,
okay.
number
and third
3.
one. Give me a third one.
I mean, I'm
give you a third
skeptical
one.
about Mars, but
Mars, that's undersurface Mars, where
Undersurface,
there might be some liquid water in aquifers.
Yeah,
I'll be your third option.
I was about to say that, but I'm skeptical. But yes,
or it could be Mars might have fossilized life.
Okay.
So the life was there; it's no longer there, but that still counts. Because it
I
ain't
would count
here.
That's
It
true.
ain't here. If we can prove that it was there, it still counts as life because it was there.
True.
Yeah.
And we have
I'll
so
give you
much, and there's so much evidence of liquid water on the surface at some point.
At one point, yeah. Oh, yeah.
Right, right.
Excellent
Super
question there.
cool. Nice
keep it going, Chuck.
Mike Parker, way to go. All right, here we go. This is Sherry Cariso. And Sherry Cariso says, hello, Dr. Shields. Do the ideal conditions for life on extrasolar planets depend on the star itself? Or are the requirements the same no matter what? Also, thank you for Rising Stargirls. I am registering my niece. You are an inspiration. Sherry from San Diego.
Thank you so much, Sherry, for asking that question, and can't wait to see your niece in Rising Stargirls workshops coming up soon. So Rising Stargirls hosts summer, we host annual virtual workshops during the summer for middle school girls of color. And that means ages 10 to 14 or 15, roughly.
Oh, wow.
No
And
one is turned away.
Virtual?
And they're virtual. So we have
so
girls
no matter where you are
that participate from all over the country, and we even have girls participate from other countries too. And we're ramping up to do even more. We also host educator webinars where we show educators how to use the activities in our handbook with girls in their own communities all over the world. So back to your question, the primary ingredients for life are liquid water, or a liquid, which on our planet is water. And as we know, we can't just look for water, but that's our first order thing. We're looking for some liquid that life can use to make its the stuff it needs to carry out its chemical processes and reactions. Some kind of energy source, whether it's the sun, the star, or chemical energy, like life that lives in the deep ocean around these hydrothermal vents, has no access to sunlight, and yet there's life there. So it's using the chemistry of rocks and heat from the core of the earth.
Can I add there that when I was taught biology, it was only assumed that life could thrive. It was assumed that life could only use sunlight because we hadn't discovered the life at the bottom of the ocean yet. So they had to broaden the definition. Not that life depends on the sun, but life depends on an energy source. So I like that's now folded into that definition. Okay, so keep going.
Yeah, thank you. And then the last one is the basic building blocks of life, like some kind of environment for life to make its, to carry out its metabolic processes and to use. So we think of this like it needs sulfur or phosphorus or oxygen or nitrogen or carbon. These are like the basic elements of life. So
the organic chemistry, basically.
The organics,
okay.
Energy source, and liquid. So all of those things are what we look for when we're looking for a planet that could be habitable. And for the part that I am really focused on is where could the climate be suitable for water to not freeze, not evaporate away, but to stay in liquid form somewhere on that surface. And so this can be affected by the type of star, as you bring up in your question, because this starlight can be different depending on the temperature of the star, how that starlight interacts with the surface of the planet, the various atmospheric molecules on that planet, that can influence the planet's climate. So it does depend on the star. But those three ingredients are the main ingredients that we think any kind of planet would need to host life, to keep life going for,
now you
a
just
long
made
time.
me think of a question, and if it's a dumb question, just let me know.
There are no dumb questions.
That is not true. You have not heard me ask questions. When people say there's no dumb questions, I'm like, just wait. Okay. So are there different stars that give off different colors and can look like our star is white? Are there different stars that give off different colors, and can those different colors actually affect the development of of life?
That is the complete opposite of a dumb question. That is a fantastic question. So yeah, I'm not going to believe anything you say now.
Okay.
It's not a tough question.
It just popped in my head. So when it just pops in my head, I'm like, maybe that's a dumbass question. I don't know.
Never. So yes, different stars have different colors. And if you are fortunate enough to live someplace where you don't have a lot of light pollution, if you go out on your porch or your stoop and look up, you'll see this. You'll see this in action, that all of the stars don't all look the same. Some of them look white, some of them look yellow, some look a little orange or a little red. And if they're twinkling, that's a pretty good bet that that's a star. If it's not twinkling, then you can be more convinced that it's a planet. There's a lot more stuff between us and a star than there is between us and a planet in our own solar system. And so there's a lot more atmospheric distortion and turbulence, and that's what we see as twinkling. But anyway, yes, the colors are real, and that has to do with the temperature of the star and how much light it's emitting. And that light, again, that's gonna, if there's a planet around that star, and just about every star in our galaxy has a planet around it. It may not be in the habitable zone, but just about every star has a planet. Then that planet, if it's got an atmosphere, if it's got a surface, that light is going to be shining down on that planet. And how much light is in what region of the spectrum, the color of that light is definitely going to influence how it interacts with what's on that planet and the weather, the temperature, the climate of that planet.
So you have one of the most complicated problems to solve out there, it seems to me, because it's not just light shining on the planet. It's like, how does the chemistry of the atmosphere interact with the light that's shining down on the planet? Does it get absorbed? Does it get re-emitted? Is it reflected? And then if it reaches the surface, then you got to worry about the surface. And somewhere in there, maybe there's life. It sounds like a really hard problem.
It is a really hard problem, because those same cool stars that comprise 70% of all stars in the galaxy, those M stars, they're really awesome because they're so numerous, and there's a lot of advantages to looking for life around those stars. But there's some disadvantages too. They have really long phases where they send out a lot of X-ray and UV radiation shooting towards the surface. And we know the reason why we wear sunscreen is that UV radiation is not good for biology. And so it could be that, life could only exist at the bottom of the ocean on those planets. It really
where you're protected
depends.
from the UV.
Where you're protected
Water is a
from
good
the
UV absorber. Yeah. All right.
Okay, cool. Super cool. All right, here we go. This is Omar Marcellino. And Omar says, hello, Dr. Tyson. Hello, Chuck and Dr. Shields. Omar here from Dallas, Texas. Dr. Shields, given your unique journey through the cosmos of astronomy and theater, two fields that are often mentioned never in the same sentence, let alone in the same career, you have boldly gone where few have gone before, and leading the way in ensuring others from diverse backgrounds can do the same through your work with your Rising Stargirls. In your perspective, how could this universe of diverse talent and experiences propel us further into the final frontier? How do you think incorporating a spectrum of perspectives in astronomy could accelerate our interstellar mission to understand and reach other worlds?
Whoa.
Now, wait a minute. Is your husband named Omar?
Is it about to be? No, I'm kidding. That was an excellently written question and recited. So yeah, I'm going to say, Omar, you want to read this book.
Oh,
look at that.
Because this has got the whole journey in there, pretty much
I see
everything.
what you did there.
Yeah.
And go to risingstargirls.org, because you'll see we're not just teaching these girls astronomy and astrobiology. We're not just saying, hey, there's stars out there, there's galaxies, these are the names of the... They get to write a poem about what they're learning. They get to design their own exoplanet and make choices about how many stars it orbits, and if there's life there, and if there's not, why not? They get to write their own constellation myths. They get to calculate the distance from themselves, from the Earth to different solar system bodies in units of themselves. So we're doing this all to develop a personal connection between these girls and the universe, of which they're an integral part. So we're processing what they learn through a creative arts-based lens. And I wanted to bring it back to Rising Stargirls because that's really my journey has been epitomized by this program of like, they're not the arts and the sciences are not as disparate as many people might think. Mm-hmm. In both cases, it's about the story, right? Everything has a story. Planets, stars, they all live, right? And they die. And there's a story of their becoming, and there's a story of their evolution, and there's a story of their deaths.
Except
right?
planets don't have mother issues.
Right.
Later in life. There's certain stories they're not going to tell, I'm pretty sure.
Yeah, the stories are different, but there's a journey.
There's stories nonetheless.
Right? Or the stories of humans on the stage or on the screen, right? Looking to live, as one of my method acting teachers used to say, right? Trying to find happiness and fulfillment. So there's that whole like science and the arts. And in fact, not only are they not as disparate as we might think, but they actually interweaving them is the key in my mind to answering your question, is to creating imaginative thinkers and enlightened scientists and enlightened artists, for that matter, realizing that these disciplines can fuel each other, can be used to elevate our core understanding of the human experience and the universal experience. So that would be my best way to answer that really exciting question.
And can I add to that, as a minimum, in a day when only men did science, it means half the population of the world, half the intellectual capital of our species was not at the table at the time anyone is thinking about how the universe works. So the extent to which you can extend that to have 100% of our species have access to, whether they choose it, that's another question. Right. But if they don't access to it, then you can ensure that we're getting the best minds who want to actually think about our past, present, and future in the universe. Yeah. And right now that is not the case.
Yeah,
that is absolutely not the case.
Physically, it was half. Percentage-wise, it was way more than half.
That's funny. Okay, it was half of the mass, but and less than half the actual brain power in the universe. I get it. I get it.
And we want these girls to claim ownership of what they're learning. Mm-hmm. You know, to know that they matter, that they're an integral part of this universe. That, you know, just in the same way that if we were to look at the Milky Way galaxy through one type of light, just visible light, right, you'd see like this thin line with a bunch of dark clouds in it, and you'd think there was nothing there. If you look towards the center of the Milky Way galaxy, that swath of space that some of us can see if we go out in the desert, if you just thought that was
some
the
of
only,
us can see.
Yeah,
the remaining 3% of the population of the world,
right?
Yeah,
where there's no extra light pollution. Right? If we thought there was nothing there, we'd miss out on so much information about this galaxy. But if we looked at the infrared, we see so much going on, right? Never mind UV and gamma. There's so much more, right, to the galaxy than meets the eye. So too is there so much more to these girls than meets the eye. And we want them to have that ownership of that star, that planet, that galaxy that they're studying, so that when they continue on and the heavy math comes in, they'd be less likely to leave the field because they think, oh, you know, I didn't get that question right on that test. Someone told me that, you know, I shouldn't be here, right? Just knowing that there's a connection that they have between what they're learning and who they are, that we hope will really help them stay.
All right, cool. All right, let's see if we can slip in 2 more questions, Chuck.
All right, well, here's one from Carrie Manneberg, and Carrie says, "Hi, Dr. Shields. Is there any scientific evidence that life on Earth came here from an interaction with a comet or asteroid that had biological foundation chemicals?"
Ooh, this is a popular question within the astrobiology community. I believe that the term for this is Panspermia.
Yes.
Right, that something comes in from elsewhere and like seeds the Earth.
Us.
Yeah. Of course it's possible. I don't think it's being given very much funding to be honest, and in terms of exploration of this topic, but it certainly has been discussed within astrobiology communities.
Okay.
Okay.
All right. Okay, this is Jason. He says, hello, Dr. Shields. Do you have any personal moral quandaries about science moving forward? Or is pretty much just forget morals and let's just see how far we can go? Now, I don't know if Jason is making an indictment of any sort or not. Well, you know, that's a very specific
It's
question.
starting out with the premise that all scientists are immoral. That's kind of
yeah, basically. But I think I know what he means. It's like scientists want to discover. What if you, and you too, Neil, had the opportunity to make a discovery that would enlighten, but there was a larger chance that it would destroy? Would you still expose that discovery? That's a moral quandary.
Yeah, this is an important question. This harkens back to the last episode that I was fortunate enough to be on with you, where we talked about terraforming and we talked about some of the moral and ethical implications of that question of, is it okay to terraform another planet or terraform Mars? I do think that as scientists, ethics must be key. So I don't subscribe to the view that, science and discovery at all costs. There's a piece that I've written for an upcoming periodical that's like, why do this? Why look for life elsewhere? Why spend billions of dollars doing all of this? And is that object Oumuamua, that first interstellar object, is it really an alien's craft, or is it just, can it be explained by regular scientific, the scientific method? I think what it comes down to is, if we go, and I'm talking about this in the context of the search for life elsewhere, there's all sorts of other, genetics and questions about cloning and all of that have their own ethical implications. But from my part of the sphere on that question, if we were to discover that we are not alone, what would we do with that information? Would we have to go and visit, or could we stay on our planet and know that we're not alone and let that information inform how we think and feel and move throughout the world? Or would we need to go? And if we would need to go and visit, could we just go and visit and then come back home? Or would we need to stay? And if we needed to stay, could we just stay and not try to conquer? Or would we have to go the way that and emulate what was done on our planet with Columbus and Magellan and all the rest, and the implications of that, right, that led to genocide? I would hope that we would be able to learn from the lessons of the past and not repeat them. And that really is what I think it all comes back to, is hope. I have no clear answer about what other scientists might do, and maybe even what I might do if given the opportunity to go to another world and communicate with other species. But I carry with me the hope that I would want to do whatever we do from a place of love, kindness, inclusivity, and welcome, and humility, to be honest. So that, I think, is the key, that to be a scientist, I must concede that there is more that out there that can be explained, and I can hold on to that humility and help and allow that to serve as a North Star for me morally. So
well, that is beautiful.
That's
as a
beautiful.
comedian, let me just say this: that ain't happening.
It's not.
That is not what is going to happen.
Well, but I got two reactions. One, how charming it was that you thought we would go find aliens on another planet and that we might exploit them. It's just.
Rather than like Independence Day and they're going to come and kill us.
Yeah. And believe me, if we go see them, they're not answering the door. They're going to play the role just like we Jehovah's Witnesses or something. They'll be like, shh, they're here. Please, don't let them. We're not. Get away from the window.
But that
I'm just
question
saying from the window.
I've never had heard anyone talk about an encounter with aliens and talk about we exploiting them. That is like never, I don't know any storyline. If you're thinking of that storyline, that is completely beautiful. That's a beautiful thing.
But of course, it mirrors what happened on our planet.
Yes.
I mean, how could I not think of it that way?
You know what I think about it? I think if they come here and they do what we do to each other,
oh Lord,
as we portray in the films, then we're creating them not based on a supposition of how they would behave, but on actual knowledge of how we did behave. So, in fact, all of the alien movies are mirrors to our culture, as you
treating it almost like a guidebook or a recipe.
Yes.
You know?
And I couldn't help. You have to publish a paper on the interstellar visitor Oumuamua. So we have Aomawa.
I know it's so close to mine.
We need that research paper.
I write in the book, I say, Oumuamua. It sounds like my name.
Yeah, that's great.
Aomawa studies Oumuamua.
That's right.
But Oumuamua is Hawaiian. And Aomawa, does that have some origins?
My parents made it up. They made up, vowel sounds. They put together, they're musicians. They made a chant up. But yeah, that sounds, I went to Hawaii
They sounded like
once.
hippies. They sound like some leftover hippies
all
right there.
The way.
Very
all
nice.
The way.
Very
well, at least you weren't named Moon Unit, okay? Or something.
Right, or Moonbeam.
Right. Or Pilot Inspector. I mean, come on. That's unfortunate.
Oh, my God.
Yeah.
But yeah, Oumuamua means messenger from afar arriving first.
Yes,
so
the first messenger. Yes. Yeah.
Very cool.
Yeah. So, guys, we got to end it there. That's sad.
Okay.
Oh, my gosh.
This is good.
This has been fantastic.
Thanks for being on, and congratulations again.
Thank you so much, Neil. And thank you, Chuck. It's great to be here.
All right. Chuck, good to have you, man.
Always a pleasure.
All right. I'm Neil deGrasse Tyson, your personal astrophysicist for StarTalk. As always, I bid you to keep looking up.